Hello there, Mr. Sutton here, bringing you the Algebra 2 6-4 Part 2 homework solutions on transformations of logarithmic functions. To graph log base 4 of x, we're going to start by making a parent table for the inverse of this, which is 4 to the x. So this is growth, meaning I'm going to go from -1 to 2 for my x values. So we have 4 to the -1, which is 1/4. 4 to the 0 is 1. 4 to the 1 is 4, and 4 squared is 16. Now for the log base 4 table, I'm just going to switch all the x and y values since these are inverses. So now we have 1/4 comma -1, 0, 1, and so on and so forth with all these other x and y values that are switching. Let's go ahead and graph this, and I'll leave myself a little more room on the x-axis to accommodate that 16. So we have 1/4 comma -1, it's right about there. And 1 comma 0 is here, 4 comma 1 is up here, and 16 comma 2 all the way over here. And we have a vertical asymptote on x equals 0 since there was no shift or anything. So we're going to do that asymptote, go through these points, and this will give us our logarithmic function. To graph the log base 1/3 of x, we're going to start by getting a parent table for the inverse function, which is 1/3 to the x. Since that's decay, I'm going to go from -2 to +1. And I know it's decay because this 1/3 is between 0 and 1. That's what tips me off. So we have 1/3 to the -2. That's going to be 3/1 to the +2, which is 9. 1/3 to the -1 is 3. To the 0 is just 1. And 1/3 to the 1 is just 1/3. We're going to switch all the x and y values now to get the log version of all this. So we have 9 comma -2 and so on and so forth for these. Graphing all that out, I'm going to leave myself enough room to accommodate the 9 there. So I've got 9 comma -2 down here. Next I have 3 comma -1, 1 comma 0, and 1/3 comma 1 up here. And because I didn't shift this horizontally, I still have a vertical asymptote on the y-axis, x equals 0. So let's graph our line through all that stuff. And there's our logarithmic function for this one. For this problem, we're trying to transform the parent function log base 1/5 of x to this g function here. In terms of transformations that are going on, the negative outside the log is giving us a vertical reflection. The -7 inside the log is giving us a shift 7 to the right. So vertical reflection, translation right 7. I'm going to start by doing the parent table of the inverse of my parent function here. So I'm going to do 1/5 to the x, and then I'll reverse all the x and y values to get the parent for log here. So we've got a decay function. I'm going to start with -2 and go to 1 for my x values. So we have 1/5 to the -2. That's going to be 5/1 to the +2, or 25. 1/5 to the -1 is just 5. Raising it to the 0 gives us 1. And 1/5 to the 1 is just 1/5. Now I'm going to switch all the x and y values to get the inverse of this for log base 1/5 of x. So I'm going to have 25 and -2, and then 5 and -1, 1 and 0, and 1/5, and then 1. For the new rules for the g function now, because this was just the original function, for the vertical reflection, let me do the translation actually. Let me do right 7 first. That's going to be x plus 7 to implement that. And for the vertical reflection, I'm just going to do a negative times the y values. So for my x's, adding 7, I have 25 plus 7, or 32. 5 plus 7 is 12. 1 plus 7 is 8. And 1/5 plus 7, we'll call that 7.2. For the y's, now I have +2, +1, still 0, and -1. So for my axes, I'm going to have to leave myself some bigger grid lines to accommodate this 32 here. So I made my x-axis grid lines go by 4s. That'll get me all the way to 32. So I have 32, comma 2. We have 12, comma 1. 8, comma 0. This has worked out really well so far, going by 4s. And then 7.2 is pretty close to 8, comma -1 down here. Since I shifted 7 to the right, that means that my vertical asymptote, normally on the y-axis, has also shifted 7 to the right. So we have x equals 7 for a vertical asymptote. And then let me just follow that asymptote and go through these lines to get my log function. To graph this log function, I'm going to first get the parent table for the inverse of the original function. So I'm going to do a parent table for 2 to the x. Before I do that, though, what am I actually doing for transformations? This plus 2 in here, I'm translating left 2 because of that. The minus 3 out here makes me go down 3. So left 2, down 3. All right, so let's get our 2 to the x table. That's growth, exponential growth, so I'll go from -1 to +2. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2, and 2 squared is 4. Let's switch all the x and y values to get my log version of that now. So we've got 1/2 comma -1, 1, 0, 2, 1, and 4, 2. And now for left 2 to get the g function, I have to do x minus 2. To go down 3, I have to do y minus 3. Let's do the x's first. So 1/2 minus 2 is -1.5. 1 minus 2 is -1. 2 minus 2 is 0. 4 minus 2 is 2. And then subtracting 3 from all the y values, -1 minus 3 is -4. Then we have -3, -2, and -1. Graphing all this out, we have -1.5 comma -4 down here. -1 comma -3 is right there. 0, -2 is here. And 2 -1s right there. Now where did our vertical asymptote go? We shifted left 2 rather. So x equals -2 is going to be the new vertical asymptote because it's originally on the y-axis. So following that and going through those points, we've got our transformed log function. For the next couple problems, we're going to be writing a transformed rule for the parent function they give us. So we're starting here with log base 6 of x, and we want to do a vertical stretch by 6 and a translation 5 down. Let me do a g function to represent the stretch here. So I'll say g of x equals 6 times f of x. So that's 6 times log base 6 of x. Next up, let me create an h function to handle this translation. So we're going to have h equals g of x minus 5. So that's going to be 6 log base 6 of x minus 5. And this is our final transformed function. For this problem, we're trying to transform the ln of x function, which remember is really just log base e if you like. So I'm going to do this in a few transformations. Let me first create a g function to handle these translations of 3 right and 1 up. So g of x is just going to be f of x minus 3, that's the 3 units right, and a plus 1 outside all of that. So f of x minus 3 inside, plus 1 outside. Applying that to the actual ln rule, that means we've got ln of x minus 3, close parentheses, plus 1. So that's the g function. But now I need to horizontally stretch this thing by 8. So to handle that, I'm going to make an h function. H is going to be g of 1/8 x, because it's opposite of what you expect for the horizontal stuff. So that's going to be 1/8 substituted in for the x right here. So we end up with ln of 1/8 x minus 3 plus 1.